Hello, everybody. Long time no see. I got some questions about one of the examples from the notes posted on Google Classroom. So I've decided to record this problem so we can figure it out together. This is a problem that says we have a box. This is a box that I drew. I have the length, the width, and the height. The problem says that the length is supposed to be 3 times as big as the width, which means this is going to have a 3W. And then they don't really tell me anything about the height. However, the problem says that I want a given volume to be 50. And I believe the unit was, let me double check here. I think unit was feet. Yeah, unit was feet for each of them. So this is going to be feet cubed. So in the volume questions, when you say formula from geometry, we have LWH, which means if we try to replace, so we are going to replace L to be 3W here, we are going to have 3WH to be 50. So this is one equation that they gave me. Now, this same problem is asking me to minimize. So the question says we want to minimize the cost. And we want to find the dimensions that will be for this box. So we need to minimize the cost. We want the dimensions for this box. Now, if we are looking in this problem, this is going to have, for the volume, different cost for each part. We have $10 per feet square on the top and the bottom. We have $6 for the rest of the parts. Okay. So we are trying to find the cost function, which will be really related to the surface area that we cover. So for the cost, we are going to have top, bottom, we are going to have front and back, front, back, we are going to have the left side, and we are going to have the right side of this box. Each of them are going to be with different dollar amount, different cost amount. This one is supposed to be 10 per square feet for top and bottom. The rest of them, each of these are going to be 6 per foot squared. So now I'm trying again to get my memory from geometry to figure out the cost. So for the top and the bottom, they are congruent, which makes two of these pieces that cost $10 each. And to calculate that part, we are going to use LW. For the next part, we are using one of them front and back that are going to be the same calculation. That's going to be $6. So we have two of them with $6 LH. And then we are going to have for the left and the right, they are again congruent to each other. So they are going to be again two of them with $6 WH. This cost we need to be minimum cost. All right, so let's try to figure this out to see what we do. For a plan of attack, this is what we are going to do. We are going to do derivative of C. I'm going to cost this to say C. I'm going to solve the C prime equals 0. We are going to have to determine what are we doing with the variables though, because there are quite a few of them here. We don't really know anything about L, W, or H. Then we are going to have to eventually, after we solve, we are going to use a sign chart to determine if indeed the critical point that we found will qualify to get us the minimum cost. So to start, we have way too many variables here. So I'm going to say C has too many variables, which means we are going to try to solve for something that might be possible to eliminate. So we could possibly, from this 3WH equals 50, we could possibly solve for H. So we are going to have 3WH squared equal 50. And then if we divide the 3W squared both sides, we are going to say that h is supposed to be 50 over 3w squared. We are going to plug this into the cost, okay? So we are going to get C, 2 times 10, so that's 20. Instead of L, I'm going to put 3W, and then I have another W, plus 2 times 6, that's 12. Instead of L, I'm going to say 3W, and H, I'm going to say 50 over 3W squared, plus 2 times 6, that's 12, times W, and then instead of H, I'm going to put the 50 over 3W squared. Now I'm going to try to rearrange these parts. 20 times 3, so that's a 60 W squared. This will become C of W. I also plugged in, I remind you, L was 3W. So I plugged this into the cost and also L to be 3W. So going back to the cost, I have 20 times 3, that's 60W squared, plus, now I could possibly reduce it here. So 3 and 3 will be 1. And then I can call out a W square and a W. So I really have 12 times 50. So there's going to be 600 over one of these W's left. Plus, if we try to reduce the 12 and the 3 to cancel this out, 12 and 3, this will be 4 and 1. And I could cross another W here. So we really got 4 times 50, that's 200 over W. These are like terms. We can call them together. C of W is going to be 60 W squared plus 800 over W. This is what we did for the first part of C. And now we are trying to get derivative of this C. So I'm going to try to do the derivative of this. I'm going to copy on another piece of paper. I'm going to copy the C of W so I could have them in the same time in front of me. So this is 60 W squared plus 800 over W. So I'm going to do the derivative with respect to W. I'm going to call that C prime of W. This will use a power rule. 60 times 2, that's 120 W plus. If we try to think about what rule to use instead of the quotient rule, I might as well rewrite. So I'm going to say 800 times W to negative 1 here. So I'm going to do a power rule, which is easier. I have 800 and then negative 1. So that is really 800 and then take the negative 1 down times W to 1 less than before, which is negative 2. So we really have 120 W and then it's a negative here. 800 over W squared because we had the negative exponent. This part here was negative exponent. Okay. Now we are going to solve C prime of W equals 0, which makes the following equation. We have 120 W subtract 800 over W squared equals 0. We have two possibilities of solving this. One of them will be if we separate one at a time, the 120 W on one side and then this part on the other side and use cross multiply, or we could use the LCD between them and still use cross multiply eventually. I think I'm gonna go with the part that says LCD. So you can see what I'm doing. LCD between 1 and W squared is really W squared, which means I need to multiply the first fraction. If you only see a 1, I need to multiply by W squared. So to respond to Megan's question about this, this is how we got the part to the third, W to the third. Okay, so I will copy this. So this is where we arrive to 120 W to the third over W squared subtract 800 over W squared equals 0. I am not going to simplify, so this is just to get me eventually all together on the left side. I'm going to put them 120 W to the third subtract 800 over W squared equals 0 over 1. I'm going to use cross multiplication to solve this. So I will do cross multiply and then I'm trying to solve for W. This will say 120 w to the third subtract 800 equals 0. Now, you notice how we have a big number here. We might be able to do a GCF, so I'm going to try to figure out what GCF might work here. If we did, so this was 800. If we divide it by 120, that doesn't work, so I can't really pull a 120. However, for sure I can pull a 10, and then I believe that there is more to go. So if we did 120 divided by 10, that's 12, but I think there is more to go, so probably we have another 4. So that means we might as well go 40. Yep, 120 divided by 40. Okay, so we are gonna do 40 as a GCF, and then I have w to the third times 3 left over, and then subtract, we have a 20 equals 0. Now, because we have a cubic equation here, we know for a fact that if we try to graph this, we are only going to get a one solution that is actually real. So I'm going to try to graph 3x to the third and then subtract 20. Or if we try to do a division the same way, we don't really have much else that we can use here. So I'm going to, just for the sake of graphing this, I'm showing you that only one solution will show. Of course, I'll have to adjust the window if I needed to graph a little bit better, but for sure only one of these solutions is going to be the one that is the single root real. The other ones are going to be complex. So I'm going to go ahead and just do the reverse PEMDAS to solve this a little bit faster. So 40 cannot be 0. 3w to the third minus 20 equals 0. I'm going to use reverse PEMDAS in this situation. I have 3w to the third equals 20. Divide by 3 both sides. We got to the w to the third equals 20 over 3. And then I'm going to go ahead and take a cubic root. So our w is really cube root of 20 over 3, which of course I have to use my trusty calculator to figure this one out. So I'm going to do 20 over 3 to the power 1/3. This will be about 1.8821. This, I believe, were feet when we started the problem, so this is going to be still feet. So the only critical point that we got was W equals about 1.8821. In this situation, I can also find what possible dimensions we have here. And then we are going to test them out with the sign chart. So I have a possible of 1.8821 for the W. Then L is supposed to be 3 times as much as this. So I have to go 3.1121. This is 5.6463. And then my H was about 50 over 3W squared. So this one I was doing 3W. L was 3W. 50 over the 3W squared. So I have to calculate this again. 50 divided by 3 times 1.8821 squared. Okay. Just for the sake of making sure that I have enough parentheses, I'll put that. And now I have 4 point, so this will be about 4.7050 feet. These are the possible dimensions that I found. Now, if I'm trying to do my sign chart, basically what I need to figure out is my W, my sign of the C prime of W, my C of W. I didn't really do the second derivative. I could, if you would like, I could also do the second derivative here, but I hope that you got the idea that now we are testing. We are going to place here a 0. We don't really know how big this box is going to be, so I'm not going to have something, a restriction on the other side. However, we know for a fact the 1.8821 will get me the C prime equals 0. Now, speaking of C prime, I will try to also recall it here so we can test it into our chart. This is what we had for the C. So if I'm trying to record something that's a 1, let's say, if I test a 1, I'm going to have 120 subtract 800. That's definitely a negative number. And then I'm gonna test something, I don't know what, 2. If I did 240 and then subtract 800 divide by 4, that's gonna be positive, which means when we try to decide whether or not this is a minimum point, because that's what we wanted, according to the first derivative test, we have going down, going up. Definitely this is supposed to be the minimum point. So C calculated at 1.8821 is definitely the minimum cost. We can also calculate the minimum cost. C minimum is gonna be C of 1.8821, which was, let's see, where was it? C of W was 60W squared plus 800 over W. These were things that I pretty much recalled from our other calculation. So now we have, if I try to plug this in, we have 60 times 1.8821 and then squared plus 800 divide by, okay, hold on, divide by 1.8821. This gives me about 637 and 60 cents. This will be for the minimum cost here is really about 637 and 60 cents. I didn't really do the second derivative because this was pretty much sufficient to just do the first, but you are welcome to take the first derivative and do it again to decide on the concavity. To be able to say that this was a minimum cost, I was supposed to have something that was a concave up graph. So pretty much that's what we expect, that having a minimum cost, definitely we are going to have something that says we are doing some concave up graph. I hope that this helps. Sorry, I'm not that great with the technology stuff, but I will try to also take pictures of this work and upload on the Google Doc that we are sharing. Keep being healthy and safe, and I hope to hear from you soon. Bye.